The first thing we're going to do is we are going to redraw this as tip to tail, because this we can't do anything with. These are all the tails and tips are in one place and all the tails are in one place. So we're going to go use that tip to tail. Now I want you to watch what I'm doing here. I'm going to go, I'll just do 6, 3, 10. No, is that what I want to do? Yeah.
6, 10, 3, 6.
Yeah, well you can do 10, 3, 6, but I'm going to do 6, 3, 10 and then I want you guys to do one in a different set of orders. So I'm going to do 6, 3, 10. So here's 6. Here's 3. And there's my 10. 6 newtons, 3 newtons, 10 newtons. Now, I'm going to go ahead, I'm going to draw my resultant, and I'm going to draw it from where I began to where I ended. Okay? So my resultant in this case ends up in what looks like to be the 4th quadrant, okay? Kind of going to keep that in mind in the back of our heads the entire time. But I want you guys to prove to yourself that it does not matter what order you put these in, okay? So I want everyone to, I did 6, 3, 10. This bit right here, that is our resultant, right? Okay. Now, like any vector that's in 2 dimensions, we can break it into components. I can come in here and I can say, here's a y component, and here's the x component. All right? But the question is, where do they come from? If we are adding these things up, where do they come from? Well, what do we do on these things? Right? For each of these vectors, can I break each of these vectors into components? I can break this, whoops, I can break this vector into components, this vector, I can break all of my vectors into components. All right? And we just saw in level 1 that if everything's on the same axis, we can just add them together. We can group them together. If everything's all on the y-axis, I can group them together. So that's the idea that we're going to do. We are going to take each of these smaller vectors, each of our individual ones, and we're going to break them into pieces. And then when everything's on the x and everything's on the y, we're going to add them up using the level 1 rules. And it's a process, but it's not a hard one, it's just a big process. Right, and you're going to end up with a y vector, and you're going to end up force in the y, and you're going to end up with a force in the x. And then what do we do with that to find our final vector? Pythagorean theorem, we're going to do the level 2. Okay? So there's lots of ways for people to do this. The one that I like the most right now is, it's kind of like a table method. Okay? So what I need you to do is I need you to write a table somewhere on your page. And it's going to be, you need to have 5 columns, 5 rows. Okay. Well, and the reason why, one's the label. All right, you have 1 row that's a label row. All right, on the top. And you have a label row on the side. Okay. We had 3 vectors, so I need 1 row for each vector. And I need 1 row for my answer. Okay. Now what I'm going to break this stuff into, so let me see, let's do our labels. I'm going to call the 6 Newton one is the force in the is force 1, vector force 1. 3 is going to be vector force 2, and the 10 Newton is going to be vector force 3. Okay, so it's F of 1. Notice that little hat, that means it's a vector. F of 2, F of 3, and at the end I'm going to have the net force. Okay? Now, the 2 things that every vector has, whoops, wrong button. Every vector has, is a magnitude, and it has a direction. That specifically, right down here, that's what we're shooting for. We want to, when we add them together, we want to end up with a magnitude and direction of the resultant vector. When we add all these together, There's one resultant, and we want that magnitude and direction. Okay? And from what we've learned over the past couple of days, anything that has a magnitude and direction, we can break that into x and y components. Okay? So that's our setup. That's our framework. Okay? Now, f of 1 is 6 newtons, and it is 72 degrees. It is 72 degrees. It is, the 72 degrees is made with the north axis, and it goes east of north. East of north. So it's 72 degrees east of north. That's going to be important just for sign purposes. Okay? The 3 Newton one, the f of 2, that is 50 degrees. And if we look at it, it makes the angle with the south axis, and it goes east out from that south axis. So it is east of south. Hang on, just fixing some writing here. East of south. Our third one is 10 newtons. Okay, and it's 10 newtons is made with the south axis, and it goes west from that south axis. So it's west of south. So it's 20 degrees west of south.
Miss, you wouldn't put the north and south first?
Yeah,
or the east?
You don't put the north and south before the east and west?
Like north.
Oh, would it make a
east.
difference, miss?
Yes. Hang on a second. I'm going to hit a pause, and I'm going to go over that real quick.
That's what you don't know.
Okay. All right. There's our setup. Remember, the idea that we're going to do is we're going to take each of these vectors and we're going to break them into their components. Okay? So let's do that. So here's my, I'm just going to sketch it over here. Here is my 6 Newton one, right? And I'm going to give my, just so I can orient myself, I'm giving myself a little axis there, right? So if that's the case, this, whoops, not that. This is my force in the y direction. This is my force in the x. Okay, x is opposite, y is adjacent. And let's see if we can remember. Opposite is sine or cosine.
Just opposite?
Yeah, if we're talking about opposite of something, what trig function? So we're going to say opposite. Yes, I know you said it too. Opposite is equal to h sine of theta, and adjacent is h cosine of theta. Okay. All I'm doing when I do these little sketches, at some point you're not going to need to do them, but for now you need to do them. You need to see what you're doing. Okay. I'm just doing that so I can see which is my opposite and which is my adjacent. Okay, so f of x is my opposite. So that means that it's going to be 6 sine of 72. And the y is my adjacent, so it's going to be 6 cosine of 72. 6 sine of 72 gives us 5.71 newtons. 6 cosine of 72 gives us 1.85 newtons. Are my directions okay? They're both positive? Yeah. It's east, which is positive, and north is positive, so there we go. All right, so 3 newtons. 3 newtons comes down this way. Give myself a little fake axis to reference myself. The angle is made here. Okay. So that means f of y, f of x, and that's opposite. F of x is opposite, and f of y is adjacent to my angle. If you guys have any questions about how I'm choosing the opposite and the adjacent, let me know now. Okay? So again, it's x is opposite, so that becomes 3 sine of 50. And the y component is 3 cosine of 50. Okay, so 3 sine 50 is 2.30 newtons. And 3 cosine of 50 is 1.93 newtons. Yes. That's going to be negative. I can do that two ways. One, by looking at what I sketched. It's going down. And I can also do it by looking at the directions I gave it. Over here on the right-hand side, I gave it the directions east of south. East is a positive. South is a negative. Okay? So we've got the force, the first force, the second force, let's do the third force. Okay, we just sketch it out. Small sketch, doesn't really matter. Comes down this way. Give myself a fake axis. I do that from where I began my drawing.
Can't we just use the real one?
Yes, actually you can. But why am I doing it like this?
Individually.
Separate, you're making.
Because it's really, I already have a lot of writing over there. That's the only reason why. Yeah, no, so yeah, if you've got room, you can do it on there. I don't care. You just need to be clear about it. Yeah, and that's why I'm doing it, so you guys can individually see what's going on. All right, so, and this is, and also to show you a technique for when you need to do it this way. All right, so that's the angle, right? The 20 degrees, okay? So that means, here's my f of y. That's going to be adjacent. And then there's my f of x. That'll be my opposite. Okay. So based on that, it is 10 sine of 20 for my x component and 10 cosine of 20 for my y component of force. 3.42 newtons.
9.4.
And what's the other one?
9.40.
All right, so now we have the values. Let's take a look at the directions. On this one, they're both negative, aren't they? I could tell that again by looking at what I drew, or by coming over here and saying what were my directions on the board. It says west of south. West is negative, south is negative. Okay. So now we've broken everything up. And we're going to kind of backtrack ourselves back to a level 1. We're going to take all of the vectors in the x direction, and we're going to add them together. And then we're going to take all of our vectors in the y direction and add them together.
Fun.
It is.
Yeah.
Exceptionally fun. I like stuff like this. It's just because I don't have to think too much about it. Once you get the pattern of it, it's all the same. 5.7 plus 2.3 minus 3.42. And that gives us positive 4.59. Now on our other side, we've got 1.85 newtons minus 1.93 minus 9.40. And that gives us negative 9.48. And now, guys, which direction, which quadrant is this going to be in? Fourth, right? Yeah, which is kind of what we thought it was going to be based on the beginning. Okay, so I need to do something here. Okay, just so I can see something. Copy. All right, so now we've got, I just kind of blew this up a little bit. So if that big highlighted thing that I drew over in the middle, okay, this thing, I can go ahead and now I'm going to draw it with its components. It's going to have its f of x is going to be negative 9.48. And it's going to have a x component of 4.59. Okay. So if I wanted to find the magnitude of this, If I have these two pieces, I can find my magnitude using Pythagorean theorem. All right? When I have these two pieces right here, use my Pythagorean theorem, so that C is equal to the square root of 4.59 squared plus negative 9.48 squared. And whatever it is, it should be something bigger than 9.48. Okay, and I want to say it's 11 point something.
It's something.
10.7?
10.53.
Really? This doesn't sound, I'm going to double check because it doesn't quite sound right to me.
Attention students and teachers, we will not have a tutoring bus today. Thank you.
Yeah, you're correct, 10.5.
Say not.
All right, so this is 10.5 newtons,
It's a tutoring bus.
late bus. So that is a 10.5 Newton magnitude. We're halfway there. Now we're going to do the angle. Okay? All right, this right here that I just drew, that is my angle with the axis. So that's my theta. That makes, oh, I labeled that wrong, didn't I? This is f of y, this is f of x. That means f of x is opposite, f of y is adjacent. Okay? All right, now to find the theta, I'm going to, yes?
I don't know if theta, what the heck? Where you, yeah, where the angle goes.
Okay, because when I took these, when I took the components, right? All right, and I drew them out, starting, doesn't matter which one I start with, all right? But I drew it and I said, okay, I'm going to do this one first. Here's my first one, and then there's my second one.
I couldn't use it the other way.
I could, and what would happen with that if I did it like this? Is what you're referring to?
Yeah.
It's the same thing, isn't it?
Well, hang on, let me show you something
The
here.
angle's gonna be different.
It is, but it's also,
You still have the same hypotenuse.
it'll still have the same hypotenuse, and what you're going to find is that this angle will be 90 minus this one. Okay, because look, on this one, f of y is your adjacent, right?
No, yeah, but I'm telling you, how do you know where to put the angle on what side?
It does. It's just however you draw it. It's going to work out because this one is the cosine. F of y is the cosine here, and f of x is the cosine here. So what you're going to end up getting is you're going to get the same amount no matter which way you do it, but this is going to be a different angle based, and this, we'd say this one we're going to say it's east of south, and this one we're going to say it's south of east, so they're different angles. But it'll work out, promise. Okay, so it doesn't really matter. I'm going to do this one right now and put this in for notes. You guys can go if you want, but I'm going to keep talking for those who are here and just to finish off this batch of notes. All right, I'm using tangent of theta. Okay, so using off of the blue one, the one on the bottom, tangent of theta is equal to opposite over adjacent. We break that tangent up by doing the inverse to both sides. Yep. So theta then is equal to inverse tangent of opposite over adjacent. In this case, the inverse tangent, the opposite is f of x, f of x. The adjacent is f of y. Yes? Yes?
Ms. Phipps, you have a phone call in the third office, ma'am.
Okay, just a second.
Okay.
All right, so we're going to take that inverse tangent of negative 4.59 divided by, oh, I'm sorry, it's positive 4.59 divided by negative 9.48. When you do that math, you end up with 25 degrees. Okay? So if I put it into the box up here, it's 25 degrees. 25 degrees east of south. Okay? Now, if we did it the other way, we would end up with what? Something like 65 degrees south of east. Yeah. As long as it's the right angle for what you're describing. Because they're the same thing, aren't they? It's going to,
yes.
yeah, it's going to make the exact same scenario, no matter how we do it. So you're good to go.
So whichever way we feel comfortable with.
Right, yeah. So if you do it this way first, you're not going to lose any traction as opposed to doing vertical first versus horizontal first. That entire thing that we did in the beginning, it doesn't matter which way you do it. It doesn't. You have to be careful about your labeling. Yeah. All right. As we've already figured out, AP Physics is a devil for the details. Okay? But, yeah. All right, guys. Thank you.